All right, we're in week 3, set 2, SWYK number 1. We're going to go through some problems here on inequalities, specifically in this case, compound inequalities and absolute value inequalities. So on this particular question, they've given me a compound inequality to start with. All right? Now, what I'm hoping that you see, and we'll use the color purple here, I'm hoping that you see the first one says that h is greater than or less than or equal to 1.7, okay? But you've also got this other one right here. H is also greater than, and you know what? It would almost be better if I wrote it out. Oh, did I already? I did already. Wow, that was dumb of me. So, yeah, I wrote it out right here. This is another way to say the exact same thing. These two things are connected together. Now, it is an and situation. You're saying that the h is bigger than 0.7, and at the same time, it is less than or equal to 1.7. That's okay. We can find values that are bigger than 0.7 or equal to, and less than or equal to 1.7. Those two things say exactly the same thing. The word and is extremely important in there, so don't just ignore it. Now, in order to change this into an absolute value inequality, so we've got that compound inequality part. Now we want the absolute value inequality. We need to know what the middle is. What's the middle between 0.7 and 1.7? So basically we're trying to find an average. So to find the average, all of you know that you're supposed to add the two numbers together and divide by 2. And when you do that, you get 2.4, and you divide by 2, and you get 1.2. Okay? You know, that's not too bad, right? Okay, so with that in mind, the part that goes in the absolute value bars, and they've already got the absolute value bars there for me, h minus 1.2. Now, why am I subtracting? The reason I'm subtracting is because it's a distance, and absolute value is a distance. And we want it to be less than or equal to, what is the distance? The distance is, so if you think about, we've got 1.2 in the middle and 1.7 up here and 0.7 down here, we want it to be less than 0.5 units, half a unit. Half a unit above, right? So basically what you're doing is you're taking this distance right here, 0.5, and this distance right here, 0.5, and we're saying that distance, we can go above and below 1.2 by 0.5 units, okay? So I don't think I used the blanks correctly here. I think I've made it look a little awkward. Yeah, because I think my less than or equal to was supposed to go in that next one, and my 0.5 was supposed to go all the way over here. Anyway, I screwed that up. What? Don't tell me these things. I don't know what my computer's telling me. Okay, let me pause this for... I wanted you also to see this. Whenever we see greater than or equal to symbols, I tried to misspell this for a reason. When we see those symbols, we're in the next few problems, we're going to be thinking of the word or. Yes, I know I misspelled it, but I did it on purpose. The less than or equal to, you notice I said less than, okay? Because those are and situations. The one you were in a few seconds ago was a less than situation, so that's why we used the word and in between, okay? Let's go down to the next one here. Let's see here. This is another one of those less than situations. So the absolute value bars are not isolated, so we're going to subtract the 3 over to the other side, and that's where we get the 15 from. Then we can split it into its two inequalities. We do have a less than situation, so we will be using the word and in between these, not the word or, but and. And of course, we're going to be adding the 5 to the other side. 5x is less than 20 and dividing by 5 and getting 4, right? So x is less than 4, and then doing the same thing down here, adding 5, that gives me negative 10, and we're going to divide by 5 again, and we get negative 2. X is greater than or equal to negative 2. I need to show you how to graph these. Okay, so less than 4. You do not want to include 4, so you're using an open circle. If it was an equal to, I'd use a closed circle. And we want to say less than that. Well, that means you're going to color everything that way. All right? Well, when you get down to the other one, it's got the equal to on it, so it is going to be a filled in circle, right? And it says greater than, so we want everything shaded this way. Because we are looking for the word and, we're talking about where they overlap. Well, of course, I can't spell the word overlap. They overlap in the middle. So we're looking for a graph that looks like it's got a closed dot on the left. What in the world? Why do I have, oh, look, I made a mistake, folks. I made a mistake. Why did I make a mistake? Because I didn't put the equal to. Now, if you're at home, make sure I did that right. Nope, I'm not supposed to have an equal to. It's like I'm making a second mistake here. That one shouldn't be there. That's the problem right there. Oh, man. Can't believe I did that. Yep. There's my mistake. We want an open circle. Whoa, let me switch to a different color. This should have been an open circle. All right, now, which one of those graphs has everything in between and goes from -2 to +4, everything in between, but open circles on both ends? Yes, of course, that's the one. On this next question, we started off, we had to add 15 to both sides. I want you to notice that I redid the problem and changed it to greater than or equal to, and from the original problem. Anyway, so I added the 15 to both sides, and then I was able to split it up because the absolute value bars were isolated. First one looks like the original with no absolute value bars. Second one looks the opposite, changes the sign of the other side, and flips the inequality. I should have mentioned that in the last problem, that I flipped the inequality. That's kind of important. It is a greater than situation, so we are using the word or in between our solutions. We went through the process of subtracting 2 and dividing by 2 for both of them, and we got x is greater than or equal to 3, or x is less than or equal to -5. These both would be closed circles. If you're talking about less than -5, that'd be a closed circle shading that way, and greater than or equal to 3 would be a closed circle shading that way. Now, the word or means I want everything, not just what they have in common, but everything. And in this case, that means I have to choose a graph that has all the points that I just described. And so I am looking at, it looks like letter D here, right? Everything from -5 on down and 3 on up. You have to include both because we use the word or, not the word and. Thank you for playing today, and we'll see you later.